to the IT conference on SAP Technologies. I'm Serban, and today we'll talk a little about sentiment analysis and spatial analysis combined somehow. Okay, so we'll just go to it. About me, so I'm a senior IT consultant at MSG, but that doesn't mean anything actually because there are just some words in Outlook, in my opinion. So really what I do is that I'm the lead developer and architect for a cloud project, and hopefully for more cloud projects, because this one is almost done. So let's see if I get redesigned or reassigned later. Okay, I've worked with ABAP at the beginning, and I don't want to work with ABAP anymore at all. Hopefully that chapter of my life is done. Let's see, at least that's my hope. Then I worked with HANA for about, I don't know, I guess a year or a year and a half maybe. And yeah, it was an interesting experience. If anybody wants to go to HANA native development, it's really interesting, but it's really challenging. So my advice, if anybody in this room is considering it, you have really to be prepared for challenges, and really stupid challenges, like not documented bugs and features that should work but don't work. So it's really a really challenging environment. Okay, then in parallel and before and after, very chaotic, I worked with UI5. So I think I'm still a UI5 expert. Somehow you will see if you like my first presentation, then I will have another one at the end. So I have the first presentation and the last one in this room. And that's about UI5 and some very interesting, I think, UI5 development. Okay, and I liked it, but yeah, I think UI5 is a very strange framework when you look at the other JavaScript frameworks, so I also moved from that, and I started working on cloud. Right, so my last area of expertise is SCP, so SAP Cloud Platform, and that's basically what I work with now. Okay, then the last thing that I want to say about me is that I was just awarded the title of Developer Hero, which doesn't really mean anything really, but yeah. It's just a nomination has to be made by somebody, the rest of the community has to vote you, and then you get named like a Developer Hero, and you have a picture somewhere in Las Vegas put with you. So I could not see physically the picture because I was not there, but somebody photoed it and sent it to me. So I have a photo of my photo, basically. Okay, good. And basically, yeah, that's it. So let's just jump into it. I guess you know that most companies have a lot, actually, of unstructured data, right? Let's think about your internet service provider, let's say. Right? Probably you have problems with it sometimes. At least me in Sibiu, where I'm from, I had problems with it a lot. So they have a lot of unstructured data from me because I made a lot of complaints saying that it doesn't work and I pay money, so I want internet. Yeah. So you have a lot of unstructured data like this, right? Maybe complaints, maybe positive feedback. Although in Romania, I expect that 90% is negative feedback for any company, and 10% is positive by mistake because they want to say something negative and they didn't know how to use the words properly. So yeah, probably it's something like that. But anyway, customers have this, right? They have a lot of complaints, they have a lot of feedback, and they don't know how to extract value from this feedback. So they also usually, depending on the data, they also have some geographical data. For example, for your internet service provider, you also have to give some kind of subscription ID or your address or something when you make a complaint, because they have to know where you're located to fix it, right? So usually this data is also geographically, let's say, has also some geographical information attached. But usually the geographical information is not latitude and longitude, because if I ask you, give me your latitude and longitude of your house, you will not know to say it, right? You just know your address, and then you have to find this geographical info from that. Okay? So using HANA, we want to extract more value from this data, right? Because if you just look at all these complaints, probably you will get depressed after reading 5 or 6 of them. But apart from that, you can't really extract something meaningful. I mean, you look at it, okay, internet doesn't work. Next one, same problem. But maybe we can find out more from this data. Okay, so let's discuss first about the data itself. So in my example, actually, I did not have access to an internet service provider, shocker, to get their data. So I went to Twitter, because there you can find a lot of data about everything. And I said, okay, let's see what feedback SAP is receiving, which very shockingly is different than this 90% negative that I said for Romania. It's pretty positive for SAP, actually. And I said, okay, I first wanted to use the Twitter API to pull this data into HANA, and then process it a little, and then do all this sentiment analysis stuff. Okay, the first problem. If you look at SAP Twitter, 90% of the stuff is just job postings, so we are hiring ABAP developers, blah, blah, and that's, of course, useless. I mean, you cannot obtain any kind of feedback from that. Then there are some ads, like companies which want to sell their SAP products, and another big percentage are just blog posts that people made and they want to share them on Twitter. So actually the feedback that SAP is receiving is very small on Twitter. There are some guys, which we will see, which complain and say, SAP, I don't like it, or they say, oh, it's great. So I had basically to mitigate this problem. I had to cherry pick the tweets, meaning I had to go through each of them and say, okay, does this look like a real person, or is it just a bot which put some advertisement there and that's it? So it was a pretty hard process in the end, but I was pretty lazy, so I just took something like 200 or 300 tweets, I think, so it's not that big. Okay. In a real-life scenario, so in the ISP, Internet Service Provider example, there probably you would not have this problem. Why? Because if you want to make a job posting, you don't go on the Internet Service Provider's website and put in a complaint with your job posting. It doesn't help you. So probably this would be solved by default. Okay. So apart from this, Twitter also has data about the location. So there are 2 locations attached to each tweet. One is the location from which the tweet was made. So if you make a tweet now, and in EU it's not by default enabled because GDPR, blah, blah. But if you're in US and they track you all the time and they know when you breathe, then you have the location from which you made the tweet. So if we were in US now, you would make a tweet here, it would appear there that you made it from US version of Ramada Hotel. If that's not possible, or apart from that data, there is also the location of the author. So when you sign up, you may write where you are located, in Cluj or whatever. So I preferred to take the location of the tweet, but if the tweet did not have a location, then I went with the author's location, right? So that's the geographical data, and the location is a string. So it's just something like Romania, Cluj, Brașov Street or something. Actually, it's not that detailed, it's just the city usually for Twitter. Okay, and this is how the feedback looks like for SAP, or a snapshot of it. So basically, a column with all the locations and a column with all the feedback. And you can see that there are some interesting feedback like, I hate new SAP, or more interesting feedback like, I love SAP UI5. Right? So there are, let's say, nice ones and not so nice ones, but yeah, we will see exactly how we can process more than just look at them and cry or be happy. Okay, so the first step, of course, is to get this data. So the data that I just showed you was an Excel file, right? So we have to do something to get the Excel file into HANA. So what do we do? Well, first I need to define a data model, right? I have to define a table. I define the table exactly like the CSV file, just the text and the address, right? Both are strings, pretty easy. Then we need to fill this table with the Excel file, so we need to import the Excel file somehow, and there are a lot of options, right? So as a developer, you have some options, And as a real productive user, you have some other options which are more suitable for production. For development, you can use Eclipse. I don't like Eclipse anymore, so I'm not sure if I recommend this. Then you can use some file. This file has to specify where the CSV file is located and what table to import in. And then the last version, which is not really possible to use it, but I just included it as to be complete, is to use the import statement. The problem with the import statement is that the file has to be located really on the database server. So it's pretty hard to upload it first on the database server somewhere on the file system and then use the import. So probably you'll not use that never, basically. Okay, for productive usage, it's a more complicated thing because it depends. How do you want the data to behave, let's say? One possibility is to use replication, right? SLT is a product from SAP which does replication, so it can replicate data from a database somewhere else and bring it into HANA. This, for example, would be a good idea if you have this internet service provider example. Probably they have a database already existing with all the feedback, and you could replicate it in HANA. SLT is pretty good that it also replicates on the fly. So when you insert a new table, a new row in the table, then the row gets into HANA as well. So this is a pretty good solution if you have an existing database and you want to move the data into HANA and to still use the existing database. The next one would be SDI or SDA. These are newer products, I never used them, but they are pretty good as well, also for this scenario in which you have a data source already existing and you want to access it somehow. And the last one would be to use SAP Cloud Integration. This one basically allows complete freedom, so you could get data from somewhere else, whatever. This would be really the solution that you could use regardless of the input or regardless of the source of the original data. Okay, so in the end, because I'm a developer and I did not want to use Eclipse, I used this file, which basically, if you look at it, I just said, where's the table, where's the file, and that's it, basically. And I just imported all the data in there. Okay, good. Now, the first processing that we did, geocoding. So our data, if you remember, our geographical data was textual, right? So if you remember, the second column in the CSV file was the name of the location, something like Germany or Bayern or something like that. But we cannot really work with text data like that. Also, I had another problem that some users wrote their location in German and some of them in English. So actually, the same location, Germany, was Deutschland or Germany. So that's also another problem. So we want to get coordinates. So we want to get geographical data, which is numbers, not text. So we apply a transformation which is called geocoding, right? The input is the location text, and the output would be the coordinates. Okay, so HANA has a built-in functionality. You can create an index, and this index would automatically geocode for you. But it has a drawback that I don't like, actually. You have to split the location into segments, basically, into components. You have to say, okay, this column in the table is the country, this column is the city, this column is the street, and so on. And in our case, our data was not split like that. And sorry, I'm not doing this manually again. So I did not want to use this because I would have to split it into columns. So then the next option is to use something from Google, which always is more flexible than SAP. And they have a free API that you can use, and you can geocode through that. Actually, I'm pretty angry on Google now, because initially this was completely free. It's still completely free, but you did not have to put a credit card. Now you have to put a credit card to use it, which is pretty shitty, but okay. And with JavaScript for HANA, then you can actually process all the data at once and geocode all the addresses. So how does it look like? Well, it looks like this. The first column, the textual data, and then we have latitude and longitude, right? So basically, this would be the result of this step, and yeah, it worked pretty good. Okay. Then the next part would be to extract the sentiments, right? So what's the point? We care how the users feel about our product, or in this case, SAP, and HANA has a built-in functionality for this. actually it's a more general purpose functionality. You can use it to analyze text, right? You could use it to analyze text at a more syntactic level to find out what are the nouns, verbs used and so on, but you can use it also for more semantics, meaning the sentiments and stuff like that. Okay. Again, there is an index that you could use, and that's a pretty good possibility. What this index does, it creates another table. You have your table, and then it creates another table, right? And this table contains exactly the tokens that were extracted, the position of the token, what kind of token, if it's a sentiment, if it's a noun, if it's, yeah. The problem with the index that I don't like, again, is that it's asynchronous. What does this mean? When I insert a row, sometime in this lifetime probably, the sentiments will be extracted, but I don't know when. So I need then to do some tricks to find out when. So a better option, for our case, was to use a JavaScript API that they have. So you could either use this index or you can use a JavaScript API, and you can extract the sentiments as you go. In newer versions of HANA, so I used HANA 1 SP11, but from SP12 onwards, you also have a procedure in the database that you can use. So if you want to do it at SQL level, you have a procedure to do this. Okay. Let's talk about the sentiments, right? So it's a pretty interesting topic. They categorize them like this. There are three main types: positive, so something like good; negative, something like bad; and neutral. Okay is neutral, for example, or yeah, I guess okay is neutral. Strong, yes or no. So basically, bad. If you compare bad with horrible, right? Horrible is a lot more strong than bad. Okay, and then the sentiment also contains the words that form the sentiment, so bad in this case, and also the position of the sentiment. Now, HANA is pretty good at detecting semantics, so if you say something like not good, it will detect it as a negative, not as a positive. So it's not like a simple text search for keywords, it really knows to understand the context. So in that way, it's pretty good. And if you think about it, good, for example, could be a negative if it's not good, could be a positive which is not strong if you just say the presentation was good, or it can be a strong positive if you say the presentation was very good, right? So then good, the word good could be 3 different things. Okay, and this is how it looks like. Maybe it's a little small. So the type, positive or negative, and the text, great. Emoticons are also supported. So here we have a positive emoticon. And then we have the index, so the position in the text where the sentiment is located, right? And, of course, the flag, if it's strong or not. So pretty interesting things. And negative emoticons, so it knows to extract a lot of stuff. And we will look shortly to see what kind of results we obtained. Of course, you may wonder how good is it to detect the context, right? Because in some cases you may be sarcastic or ironic or stuff like that, and actually HANA does not really deal that well with sarcasm. So a good thing, as I said already, is that it understands emoticons. I tried a lot of emoticons and it knows most of the really used ones. For example, the heart one, it doesn't know. So if you make the greater than, no, less than and then 3, then it doesn't know to understand it. It also understands ratings. So for example, here it's a 4.5 rating, 4.5 stars, and it understood that it's a good thing, 4.5 out of 5. If I would have written 1 star, it would have said that it's a very strong negative because it's 1 out of 5. So this was pretty nice that it understood that. But if you use sarcasm, or here is not even sarcasm, I would say, in which the guy complained and then he said that this one is more than outdated and put a positive emoticon which is somehow sarcastic or ironic, then it took it as a positive sentiment. So this was not a positive thing, that's the, I don't know what note is outdated. Okay, then it doesn't understand the context. So here the guy said, I shouldn't have to make 4 clicks to approve a single line. Okay, and it took approve as a positive because basically the meaning would be positive somehow. But overall, this would be a negative sentiment, right? Because the user has the expectation that he does one click and he does 4. So, okay. And then there are some sentiments that the HANA does not know what to do with them, or some tweets that it ignored. So for example, this thing that trust is growing, this would be a positive thing, or the report is missing since nearly a year, how long will it take? This again is a negative overall sentiment that SAP, it did not deliver something. Or after the giant useless SAP update, which useless clearly should be a negative in this case, I noticed nothing different other than less hard drive space. So again, this I would have expected to be a negative sentiment overall. Okay, now finally let's talk about visualization. So now that we extracted the coordinates and then we extract the sentiments, we want to mash them together somehow and to extract some, let's say, insights. Let's think about what insights we could extract. Well, in the case of the internet service provider, it could be very interesting to detect if there are some neighborhoods from which we always get negative feedback. What would that mean? Well, it could mean that the infrastructure is failing or is shitty. Or maybe one of the neighbors is torrenting all day and is taking the bandwidth of everybody, or stuff like that, right? So for some customers, clearly it's very important to see where the negative or where the positive is coming, right? If you have a hotspot of positive feedback, that means that that area is okay and it's going well. A hotspot of negative feedback means that you need to take some actions there and to try to find out what's the cause and so on. So HANA can help you to find the hotspots like this. Of course, it can also help you to understand more. For example, we could correlate this feedback with products. So HANA knows to extract also product names and company names. For example, SAP, it detects it as a company name. ABAP, it detects it as a product. It is somehow a product, I guess. So you could also correlate feedback with the product or the thing, the topic that is discussed. Okay, so as I said, we basically transform the unstructured data into somehow structured data, right? So we have sentiments and we have the geographical data, and let's visualize it. So first, I tried to also derive a score for each tweet. So something like a rating. What would be the rating that the user would give to SAP based just on his tweet? So from 1 to 5, where 1 is bad and 5 is good. So if you don't have any sentiments, then it's a 3, because it's somehow in the middle. If you have a lot of positive sentiments, it's a 5. If you have a lot of negative, it's a 1. And all the scale like that. And the first element of visualization that I built was a simple table, and we can see exactly each sentiment where it's located, right? So if it's bold, it's strong. If it's not bold, it's not strong. And green would be positive, and red, well, I only showed positive feedback because we like SAP, right? So we only see green, but it would be red for negative. And here we see the score. So here I actually ordered by score, so we just see the 5 score ones. Okay, and maybe a better way to see it would be on a map. So we can also build a map and see exactly where is the feedback located. And we can see when clicking on one, what's the feedback. Also, the markers are color-coded based on the score. So if it's yellow, if it's in the middle, it's green if it's good, red if it's bad. So this could be, for example, one way of seeing, getting one insight from a geographical perspective. But to really find the hotspots, like we discussed, we would need maybe a better way, right? I mean, you could visually look at the map and somehow try to find the hotspots by yourself. But if you have like a million points on the map, then probably everything is just filled with markers and you cannot understand anything. So we could use something like clustering. HANA has 2 versions of clustering. One version of clustering is DBScan. DBScan is pretty good because it knows to connect somehow points which are near to the one to the other. So it doesn't try to just group them all, let's say, like gravitationally based, right? So if you would imagine that you have all the points in space, probably through gravitational law, they will all get collected into some center somehow. DBScan just tries to form contours somehow. So if they are really one next to the other along a river, for example, it would know to group them together like that. Another clustering version would be to use k-means, which that really just groups them based on distance one from the other, and doesn't really care to connect ones which are next to the other and to make let's say groups which are not circle based. Okay, and the other version that I like more actually, which is because it's nicer to see, is to use Google Maps. So Google Maps has a possibility to cluster points together and to create some kind of markers which are for clusters, right? So let's see how it looks like. It looks like this, and you can see where is your feedback located, right? So where is the center of the groups, let's say, and using this you could easily find where is the feedback concentrated in. Of course, you could filter just for negative feedback and to see the groups just for negative feedback or just for positive feedback. And this, of course, could help you find at a lower scale, if you were just in Germany or just in Cluj, you could find the neighborhoods where you have problems if you're an internet service provider, right? The next idea, if you think about companies and how they are organized, usually companies are organized somehow in divisions or groups or sales organizations based on geographical boundaries. So for example, I don't know, Metro, I know for sure, is split into 3 or 4 regions in Romania, and basically sales are aggregated for those regions, and also feedback and everything is based on that region. In IT companies, usually there are departments which are somehow functional, so in MSG that's the case, and then you have some kind of competition between departments, or in the case of Metro, between regions. So probably some companies would be interested to derive geographical areas and to aggregate the feedback for those areas. What would this be useful for? Well, one regional manager would say to the other, I have a 4.5 rating and you have 3, so that means that I'm better than you. So this could be, for example, a use case, right? So to derive this boundary, we also built a UI that allows you to draw. Of course, you could import the existing shape, but in this case, I just drew the polygon or the region, and then for that region, I computed the average score. So inside, I found 10, and the score was 4, the average score. And the outside region had the average score of 3 point something. So based on this random region that I drew, these guys are better than the rest of the world in this case. Right? So that's basically what you could derive. Of course, afterwards, you can do a lot more drill down and stuff like that. This was just meant as a simple example. Okay. So that's about it, just as an introduction to this concept. The code is available also on my GitHub. So what I would like to say in closing is that I think that HANA delivers a lot of functionality built in that you could use very easily. So all the stuff that I showed, apart from the UIs, which were in UI5, are just a few lines of code, right? So to extract the sentiments, I wrote 1 line of code, basically. To geocode, I had to write 2 or 3, but if I would have used the HANA version, the geocode index, then it's 1 line again. So it's very easy to derive, and also for clustering, it's 1 line of code. So you can derive all of this stuff just with a few lines of code, and with pretty interesting, at least, output, right? If we think about the local market here in Romania, I'm sure that RDS would really need this, because there are some areas which are really completely destroyed from the infrastructure point of view, so they could find it out using this. Okay, and as a closing, I would like you to also give feedback. This link you should use throughout the day, because I also have a stand, and yeah, this link is for my stand to collect some data. So if you go to this link, to itconferencesap.com 2018 and feedback, then, or you scan this QR code, then there you can give some feedback for this presentation or the conference in general, and then we can go to the digital launch in 2 or 3 hours, I guess, and you can see the results. Okay, and you can follow me on social or on GitHub or on SAP. Okay, thank you, and questions, if anybody has questions. Yes?
Is there support for some other language than English?
Yes. Yes, so HANA has support for, last time I checked, something like 20 or 30 languages. I don't know by heart which languages, but it's German, French, Spanish, all the big languages. And it also knows to auto-detect languages. So you just have to give the text, and it tries to guess, like Google Translate does, tries to guess what's the language.
Have you tried maybe some other language?
Yes, well, Romanian was not supported when I tried it, but I tried German and it knows to. So German and English, those are the two that I tried.
And does English better perform than
Yes,
German?
yes, yes. So I think English is clearly the one in which they invested the most time, and the others probably not that much. Also, the text analysis can be used for multiple things, not only sentiment analysis, and each of these configurations that you can use, for example, just syntactic analysis to find the nouns and so on, some of them are not available in all languages. So sentiment analysis is in English, German, and I think 1 or 2 more. And general text analysis is available for 20 languages, as I said. So I think they invested most time in English. And then German, because SAP is a German company, or at least the roots are in Germany. And yeah, the rest of the languages, not that much. Okay, other questions? Okay. If not, then please feedback, and I hope you enjoy the rest of the day, and I hope I see most of you back in, I don't know, 3 hours or when my next presentation is. Thank you, and see you.